In this question, it says the decomposition of solid KClO3 can produce small amounts of oxygen gas and solid potassium chloride. How many grams of oxygen gas can be isolated from 4.50 grams of KClO3? So the first thing we need is a balanced chemical equation. And so we know that we have KClO3, and in this case, it's going to be solid, and we know a decomposition decomposes. And so we have oxygen gas. Now, oxygen is a diatomic, and so that means it comes as O2 gas plus potassium chloride. And we know that potassium is K plus and Cl is Cl minus, and so that just gives us KCl, a solid. So now we need to balance this. As we can see, there's one potassium on both sides, one chloride, but there are 3 oxygens on the left and 2 on the right. And so when we put a 2 here, that would give us 6. So that this needs to be a 3. And then we have a 2 here. So now this is balanced, 2 potassium on both sides, 2 chlorides, 6 oxygens on both sides. So now we just want to convert from reactants to products. So we're going to take our 4.50 grams of KClO3. Then we're going to convert that into 1 mole of KClO3 using the molar mass, which is 122.55 grams. So then we're going to use the stoichiometric ratio, the big numbers out front. So there are 2 moles of KClO3 for every 3 moles of O2 gas. And so it asks for grams of oxygen gas. So in 1 mole of O2, there are 32.00 grams. So when we plug all of this into our calculator, we get 1.76 grams of O2 produced in this problem. So the key points are to make sure that right here, we're using the stoichiometric ratio so that we can go from grams to moles, and moles to moles, and moles to grams.